Hey guys, this is a really nice one, and honestly, it looks way more complicated than it actually is. So here's the setup. Let's just walk through it calmly. We have three circles, all tangent to each other. The circle on the left has radius 3, the circle on the right has radius 2, and the circle on top has radius 1. And right in the middle, between all three circles, there's this small gap, and that's what we want to find the area of. All right, before we jump in, you know the drill. Pause the video for a second and see if you can think of a strategy. Where would you even start with something like this? Okay, let's solve it together. First big idea, instead of staring at the curves, we focus on the centers of the circles. If we connect the centers of the three circles, we get a triangle, and something really nice happens here. The distance between the left and right centers is 3 plus 2, which is 5. The distance between the left and top centers is 3 plus 1, which is 4. And the distance between the right and top centers is 2 plus 1, which is 3. So the triangle formed by the centers is a 3, 4, 5 triangle, which means it's a right triangle. That's already a huge simplification. Since it's a right triangle, we can immediately find its area. Half times base times height, half times 3 times 4, which gives us an area of 6. Now here's the key idea. That region is what's left after we remove 3 circular sectors from this triangle. So we're going to take the area of the triangle and subtract the areas of the 3 sectors. Quick reminder, and this is important, the area of a sector of a circle is 1/2 times the radius squared times the angle, measured in radians. Now let's name the angles of the triangle at the centers. Let's call them angle A at the left center, angle B at the right center, and angle C at the top center. Because it's a 3, 4, 5 triangle, we can actually find these angles using cosine. For angle A, the cosine is 4 divided by 5, so angle A is arc cosine of 4 over 5. For angle B, the cosine is 3 divided by 5, so angle B is arc cosine of 3 over 5. And angle C, since it's a right triangle, is 90 degrees, or pi over 2. Now we subtract the sector areas one by one. At the left center, the radius is 3, so the sector area is 1/2 times 3 squared times angle A. At the right center, the radius is 2, so the sector area is 1/2 times 2 squared times angle B. And at the top center, the radius is 1, so the sector area is 1/2 times 1 squared times angle C. So the area S is 6 minus 1/2 times 9 times angle A, minus 1/2 times 4 times angle B, minus 1/2 times angle C. When we plug everything in and simplify, we end up with an exact expression involving arcosines and pi. And if we want a numerical value, that comes out to approximately 0.4643 square units. And that's the area of the gap. Pretty elegant, right? If you enjoyed this one, go ahead and hit like, subscribe for more geometry puzzles like this, and let me know in the comments if you saw a different way to approach it. All right, thanks for watching, and I'll see you in the next one.